All right, you can all hear me at the back? Yes? Good. I'm glad we went out for the photo because everybody's woken up now, so I can all put you back all to sleep again with this a fascinating subject of banking interchange formats. This is a companion talk to the one I gave on Monday. It kind of explains what we're dealing with in the system I talked about. So first things first, does everybody know what that is? Yep, it's the holoref encoding of the 1964 EPTDIC character set, aka the root source of all technical debt for what I'm about to speak about. Very brief history of banking. So it all started literally as bookkeeping, ledgers, writing stuff down in books, hundreds of years ago. Automation started to appear end of the 19th century. So W.S. Burroughs put this patent in for a mechanical calculating machine, make life a bit easier. Then the same company, 60, 70 years later, came out with this thing. Computers, terminals, mainframes are adopted in the banking industry. So this is one from Burroughs. There were several other manufacturers at the time, but IBM and Burroughs were kind of the two big players in the industry. And it supported COBOL. You know, you can program in English. It's easy. And they had all these peripherals to allow you to read and write punch cards, the thing on the first slide. And these things became widely adopted. So, of course, any constraints and standards of the systems became widely adopted. And some of those are still widely adopted to this day, 60 years later. So what am I talking about? I'm talking about interchange formats. This kind of stuff. So moving money between banks, requesting an authorization for a payment, querying balance information, many other things. I'm going to talk about each one in turn. I'm going to go quite quickly because I've got a lot of material. But it kind of repeats itself, so you'll be very familiar with this by the end. So the first thing is proprietary formats. And you'll find these everywhere, and they're used for all sorts of things. Sending batches of payments, asking for authorizations, statement data. They're often derivatives of existing standards. So you get a spec for a standard and an example file, and you look at it and you think, kind of looks like this other thing, but not quite. Or it's just completely bespoke stuff. And usually this stuff is decades old because they've written their own thing and a standard has come out and they can't really move to that standard because banks tend to move at a glacial pace. Too much risk involved in making changes for that kind of thing that I spoke about on Monday. So this is an example of one of those proprietary formats. I've wrapped it to fit on the slide here. It's a little bit opaque. Well, it's very opaque. It's not very human readable. I mean, you can see a few bits of information in there, you know, the text, but obviously there's going to be account numbers and amounts and currencies. And so this is from the test suite for one of our banking integrations, sending batches of payments to various beneficiaries, all that kind of stuff. So how would you parse or construct something like this? How would you parse it? Any suggestions? Yeah, it's fixed format. So pack, unpack, pretty straightforward. You could use a regex if you wanted. Maybe split if it's got some stuff in there to allow you to split it. String concatenation, sprintf, all that kind of stuff. Custom grammar even, maybe. Maybe a template if you're constructing it. That might make it a bit more legible, maybe. But I think the point is, for most of the stuff I'm going to show you, the parsing and the creation is easy, especially with the Perl. You know, Perl makes this so easy. Test coverage is really easy. Yeah. Next format, BAI2. So this is a Bank Administration Institute. So this is used for statement data, so getting information about transactions, balances, all that kind of stuff. This was kind of related to a format from 1971, and then they formalized it in the early 80s, and then they released version 2 in 1987. And yep, it's still being used. So almost 40 years later, you'll still see this. It's a CSV, but restricted to 80 characters. So there's some of that punch card lineage. Kind of uses continuation records to get around this. So you see these slashes marking the end of the line, and then it needs to carry on the next line. So it's a little bit annoying to deal with. because you kind of need to keep state a little when parsing it, but that's not how I do it. I just do a first pass and put the records back together again. And then you don't have to worry about it. You can just throw it to text, CSV or whatever, and it's easy. We're not constrained to max of 80 characters, so we don't care about that nonsense. Next one, BACS standard 18. So this is a banker's automated clearing services. This is a standard out of the UK, I think. It's standard version 18 is at least 25 years old. But the standard itself kind of goes back to the 60s and the 70s, like most of them. It can be a little bit difficult to put together the history of some of this stuff. Yeah, so pretty much all UK banks speak to one another using this format. It's widely adopted in one form or another in many other countries. So you find a spec from an Indian bank and you'll look at it and it'll look like that. So you think, oh, this has come out of the BACS standard. And it's kind of similar to the first one. So it's fixed width, but you can see it's maybe a little more readable. It's got, you know, records, volume 1, header 2, So it's a little bit more legible, maybe. Still not great. So APACS, the next one. This is various hand-wavy standards. These are the standards that they have. So interchange stuff, data format stuff, card acceptor stuff, card acceptor to acquirer stuff. The point here is that APACS don't create specifications. They define standards for specification. So a meta specification, maybe? So what happens out of that? Well, every bank creates their own specifications based on these standards. Yeah, it's like that XKCD comic about standards, essentially. It's better than nothing, yeah. So this is an example. So whenever you make a credit card, debit card payment in the UK, and many other places using a card terminal, you know, contactless, online often, this is what gets sent over the wire to the acquiring bank. And if you look at the ends of the bottom two, they start the same and then they differ. So what's going on there? How is this being parsed? Because it's a little bit of a schizophrenic format, maybe. Non-printable characters. So you split up or construct the string using various separators. They're actually quite useful, and the implementation is kind of elegant. They're a hangover from the early days of the ASCII standards. And I don't know how common these kind of separators are in other IPC stuff, but it works. If I open that very same example in Vim, you can actually see the invisible characters here. So I've got my cursor over this, and I hit GA, and it tells me it's the unit separator, and it's, you know, hex 1Fbox or 37, all that kind of stuff. So again, it's a little bit opaque unless you can open it in something that can show you those characters. This was clearly designed for narrow bandwidth constraints. So that one has actually mostly been replaced by this standard, so the ISO 8583. We're getting somewhere now, an ISO spec, ISO standard. So that's got 3 versions, the most recent being a little bit older than 20 years now. But we're still talking 40 years in, you know, many cases. And much like APACS, it's a meta specification, but it's a self-describing format, so it's more difficult for people that are implementing it to kind of deviate from that standard. And there's no annoying or nasty surprises. And what I mean by that is this example here. So I've truncated this quite significantly. I think it was 5 or 6 lines long. But the first part of the message has the message length. Then we have 4 characters to describe what the message is. So this is the version. It's an authorization request going to the acquirer. And then the key thing here is we have a bitmap. So the bitmap describes what fields will be present in the rest of the message. Again, it's a bit opaque just looking at it, but it's pretty easy to parse this as well because of the bitmap. So you get all the content of the message, and you can just parse it quite trivially into something like that. I've removed some of the data for brevity. Then we get onto the other side of the pond. So NACHA, the National Automated Clearinghouse Association, which is the electronic movement of money in the US, North America. Again, it roots to the early mid-70s. They write the standards, offer accreditation, run a lot of the infrastructure. And an example of that, well, I'm not going to show you text again. I'm just going to give you the picture from the spec. So yeah, another plain text fixed width format. Seeing a recurring theme here, kind of. Checks are still a thing in the US, and they're used extensively. And they have automated systems in place to deal with them. I hate it. I absolutely hate it because we had to deal with it. We don't have to deal with it anymore. But
1 month. What's the problem?
yeah.
You are part of the problem.
Yeah, I might give a lightning talk about this in the future, but I don't have time to rant about it here. So on to the next spec, which is Swift. So you've probably heard of this one. So it's an open global standard for financial information. So a global standard, so we're getting somewhere. It means many things in the financial world. So the secure network for transmitting information, a set of syntax standards, and a set of connection software and services. They define all of these message categories. I'm not going to go through them, but they have this knowledge center. There's a link down here, which is actually really, really good. Specs very clear, has examples, has change logs. Publicly accessible, which often these specs are not, which I'll get to. But this is one of the things we deal with. So this is statement data, MT940. Less opaque now. We can clearly see that we've got certain record types, and we can see transactional data, and I can just about read that having looked at it enough. But again, this is fairly easy to parse, plain old text. The spec has its own custom grammar, so they describe various fields and all that kind of stuff. But it has annoying inconsistencies. So from that, we can see that we have 2 dates and they have different lengths depending on which thing the spec it is, and a 6-digit date. So Y2K never happened. They can't change the field lengths because it would break everything. So we have to deal with this kind of stuff. Another ISO spec, so ISO 222 or 2002 or 20022, I don't know. This was introduced by Swift as well, so a single standardization approach. It's all the methodology, the process, the repositories to be used by all financial standards initiatives. So the first edition includes 8 parts. This was published about 10 years ago. UML profile, we can kind of maybe see where this has come from. XML schema generation. Reverse engineering, what? So they have a standard to describe how you can reverse engineer other standards so they can be written for their standard. I told you some of the history was difficult to put together of this kind of stuff. So they've literally written a standard which you can get for 177 Swiss francs to figure out how to reverse engineer other standards.
This is another meta standard.
Mm-hmm. Yep. There's loads of these for sending payments, for handling money, all sorts of stuff. I'm going to give you a short example here that's heavily truncated that we are using. It's payments initiation, or PAIN. And they couldn't have used a better abbreviation because all of the elements in the XML are heavily abbreviated. This, I tell you, it's peak Java Enterprise XML stuff. And I appreciate that the Swift people are smart, but who designed this? I mean, really, Why abbreviate XML elements and this poorly? Acknowledgement has a longer abbreviation. Acknowledged has a longer abbreviation than acknowledgement. They abbreviate French to French, just removing the E. It's very, very strange. And it can't be about file size. You think it would be about file sizes, right? Because we're sending these big XML files. And no, because the transactional elements use end to end, literally spell out end to end, rather than something shorter. So if they used E to E, they would save a kilobyte for every 200 transactions. So I don't understand. And this must be a nightmare if you're not a native English speaker, because I look at it and it's just so opaque, some of it. I'm sure if I paid the almost 1,000 Swiss francs to get all 8 standards, it would make sense, but I'm not convinced.
There is a website for it?
There is a website that has all of the tag names, and yeah, it's...
But all more and more countries, the banks are moving towards this.
Yeah, so many banks are already in the process of supporting it, and we've had emails the last 2 or 3 years saying, hey, we're going to start using the standards, so you need to start testing. What about some more modern, newer kind of stuff? So shiny new APIs, go cardless Stripe. Yeah, modern. Lots of third-party libraries are available for this stuff. RESTful. REST meaning reinvented every single time, as I say. These are very nice to deal with, but they're just abstracting all the stuff that I just showed. So that comes with an added cost. They're handling the technical annoyances around all this. And if you reach significant size or volume, you're probably going to want to do it yourself anyway, because if you're using these, you're going to get costs, and you probably want to get rid of those costs. So we are using Go Cardless in the UK for direct debits, which is great because the direct debit system is not amazing to deal with. Open banking APIs, you've probably heard about these. But this is mostly consumer facing, so it's not the back-end stuff I just talked about. So they don't really address our use cases and our problems and what we want to do. However, some companies are actually addressing some of the use cases. So they're putting the piping together to effectively replicate what you might want to do. This is a site that has a list of all the banks and what APIs they support and what integrations they support, and this is quite interesting. One of the ones we're using in the UK is called TrueLayer. So they effectively replace direct debit for us. So they allow us to pull money or for tenants to make payments, and we don't have to do any back-end calls to the banks. They handle it and then send us a file and move the money. This kind of open banking stuff might actually threaten Visa and MasterCard's domination in the long term, maybe. So just quickly, I just want to talk about some of the fun around some of this, so the gotchas. I mentioned these on Monday, so sequence numbers, making sure files are processed in the correct order, but banks will use load balancing and not process in the right order, so that happens. Fixed field and line width, so you think banks would do validation, but we've actually pushed files with mistakes that have longer lines than they should be, and they didn't reject them, they just pass them anyway. So they might not be doing validation on their side. Inconsistent formats, so we send a file that's an ancient plain text with fixed width, and we get an XML file back as a response because they probably bolted that response on 10 years ago, and it's easier to do that than actually change the original format. Y2K never happened, like I said. There's far too many obscure acronyms and abbreviations. Yep. Page 2, gotchas. So mistakes and specifications. I'm not exaggerating when I say I've found multiple errors or inconsistencies in every single banking specification I've ever worked with, including those from ISO, APAC, Swift. Contradictory examples, out of date information, just wrong information. And I'm not being snarky here, it's just the nature of having multiple 100-page PDFs iterated on over decades. It's become some sort of technical semantic satiation, and people work on it just don't see the errors. And then you try and implement it, and it's like, it's not working. Why? rarely see change logs, and I find this extremely annoying. They'll send an update of the spec. Here's version May 2025. Here's this 200-page PDF. And it's like, great, what's changed since the last 200-page version of the spec? Swift do show changes, but they don't publish a full change log. It's just what changed from the previous version. So it's kind of like you have to hop through the versions to get the history. Specifications can be hard to find, or they're hidden behind some sort of registration thing, or they cost a fortune. And the specification docs can be actually hostile to the users. Lacking change logs is an example. The other example is they don't have examples of what they're speaking about. So we have a spec for one of the banks that's 200 pages that describes the file format, but they never show you the file format. There's no example in the spec. And when they do, they have a screenshot of some mainframe interface rather than the plain text. So this is from Bax. I had to feed this through ChatGPT to convert that image into the plain text format. So it's a bit hostile if you want to copy paste that into Test Suite and work from it. Very quickly, the state of CPAN. So there's little to no code out there to parse most of these formats. Maybe that's not surprising because it's like back end of the back end stuff, and it's also so easy to do it that maybe those that have worked on it didn't decouple it. It's just in some business logic somewhere. Maybe. There's a few bits in here for the modern formats. So Mark has a distribution that handles the ISO 222, updated, I don't know, a week ago, 2 weeks ago, very recently, keeps it up to date. The ones that do exist for the other formats are maybe out of date, or they don't have test coverage. So I found a few things on GitHub in Perl, but they don't have any test coverage. And that's like, it's table stakes level stuff for this kind of code. Like, you're moving money, it's trivial formats, it should have test coverage. Lots of libraries in other languages. I found Go, Python, JavaScript, maybe Rust, I can't remember. Good test coverage, actively maintained. And then the more modern RESTful stuff does have libraries on CPAN. I know because I wrote them and published them. And they're actively maintained by me. I probably don't have time for questions, but give it